Hello, this movie's about learning target 5, determining whether two lines are parallel. So in your groups, you worked on the worksheet, Unit 3, Theorems, Making Sense of Parallel Lines. So now you know sometimes you are given lines parallel, and other times you need to prove lines parallel. So the first theorem that you dealt with was the converse of the corresponding angles theorem. Notice this says, if we can somehow prove 2 congruent to 6, then we can say that lines are parallel. Go ahead and add that to your geometry handbook. Pause the movie and then press play when you are finished. Now that you've added that, let's look at this diagram. Which lines are parallel? If one is congruent to 2, justify your answer. Go ahead, press pause. Try this on your own and press play when you are finished. All right, we have 1 congruent to 2. 1 and 2 are what kind of angles? Well, sometimes this becomes difficult, but if I take 1 and I highlight the side rays, and I do the same for 2, are you able to identify what 2 lines must be parallel? Well, you can see that A and B are the only 2 lines that I used that were sides of angles 1 and 2. So A must be parallel to B if angle 1 is congruent to angle 2. Now, the reasoning would be the converse of the corresponding angles converse of the corresponding angles theorem. By the converse, you're proving lines parallel. So when 1 and 2 are congruent, then A is parallel to B. Let's look at the next one. Which lines are parallel if 6 is congruent to 7? If I highlight 6 and 7, and I highlight the angles or the sides for each of those, I've got that side, that's the side of 7, they share this. Then I've got B as my transversal, but really L is parallel to M if angle 6 is congruent to angle 7. And that is by the converse of 6 and 7 are corresponding angles, converse of the corresponding angles theorem. Okay. That's what we just talked about. So we have all of these converses that we need to add to our handbook. The converse of the alternate interior. If I have alternate interior congruent, then lines parallel. The converse of the same side interior. If same side are supplementary, then lines parallel. It converse of the alternate exterior. If alternate exterior congruent, then lines parallel. So go ahead and pause the movie, add that to your geometry toolbox, and press play when you are finished. All right. So we have deductive reasoning where we're given something and then from that we can deduce other things. Well, ways to prove using deductive reasoning include 2-column proofs. That's your statements and your reasons. We also talked about this thing, paragraph proof, where you would need to write sentences, and in each sentence you would have your reasoning coupled with the statement. But there is another way to prove, and it's called the flow proof, and I just want to introduce you to this idea. I don't want to force it on you, but you might actually like this way of proving things to be true. So I'm going to show you what it looks like. Let's take this example. We're proving the converse of the alternate interior angles theorem. And you can see down here in the red, we have our statements. We can say 4 congruent to 6 because a given. 2 congruent to 4, they are vertical angles. 2 congruent to 6 by the transitive property used right here. And therefore, since I could prove 2 congruent to 6, L is parallel to M by, if corresponding angles are congruent, then lines are parallel. Or you could have the converse of corresponding angles theorem. So if I took this proof, I could create a flow proof up here. Notice, the given is right here, where I had the statements on top and the reason underneath. Then I know that 2 and 4 are congruent because they are vertical angles. Now what's interesting is, given each of these, I draw an arrow from each of those, I can conclude that 2 is congruent to 6 because of the transitive property. So the flow proof is just that. It's creating a flow of ideas that when connected can give you another statement. Then from that, I can say lines are parallel because of the converse of the corresponding angles theorem. So that's the difference between a flow proof and a 2-column proof. Feel free to try out a flow proof if you'd like. It is not necessary though. Pause the movie, see if you can find the error in this proof, and then press play when you're finished. All right, so in this proof, we've got that the lines are parallel, and we want to prove 2 congruent to 3. So let's check it out. Is that okay to say? Because of given? Absolutely, I can see that here. Can I say 1 congruent to 3 because of vertical angles? Absolutely, because I have that right there. They are vertical. Now, can I connect 2 and 3 and say 2 and 3 are congruent? 2 and 3 are congruent because they are alternate interior angles. Can I say that? The reason you cannot say that is because that is what you're trying to prove. So, you cannot use what you are trying to prove in your proof. Always remember that. So that's why that is illegal. You cannot say that. That's what you're trying to prove. So notice sometimes you're going to be given lines parallel and you need to prove a relationship between the angles. And other times you're going to be given a relationship and you're going to need to prove lines parallel. And that is the twist in Unit 3. So let's look at this. Up at the top, we are given lines parallel for this proof. You can see it's up there in blue. Then down here, we want to prove lines parallel. So what I want you to do is think about these theorems in the theorem bank and decide which of these theorems would you use given lines parallel, and which of these theorems would you use if you wanted to prove lines parallel. Press pause, try this, and then press play when you are finished. All right, let's look at this. Given lines parallel, we can use corresponding angles congruent, alternate interior angles congruent, alternate exterior angles congruent, same side interior angles are supplementary because we are given lines parallel. Now, if we want to prove lines parallel, the only thing we can use is the converse of the corresponding angles theorem, the converse of the alternate interior angles theorem, the converse of the same side, and the converse of the alternate exterior. So notice the converses are used to prove lines parallel. So you can think of the shoe as a converse. To prove lines parallel, you got to put on your Converse shoes. Now, let's look at this proof. Pause this movie, try this on your own, and press play when you are finished. Okay, now that you have tried this proof, you may or may not have followed the steps or the reasoning that I'm going to show you, but if you were a little confused, then hopefully I'll be able to help you out with some ideas. So we've got given lines parallel. So we know, we are proving lines parallel. My bad. We don't know these lines are parallel. We can't say that. The thing that we are given is that 1 is congruent to 2. So that's our first step. 1 is congruent to 2, given. Now notice we are proving the alternate interior angles converse. So can we use the alternate interior angles converse? No, we cannot. So What else can we say? Can we say that 3 and 2 are congruent? What's our reasoning for saying 3 and 2 are congruent? You're right. They are vertical angles are congruent. So let's see. We've got a relationship now between 1 and 2 and 2 and 3. So what do you think we can say about 1 and 3? Well, 1 and 3 are congruent. And so when looking at this relationship right here, what led us to that conclusion? Well, the transitive property did. I would also accept substitution on that. Now I've got 1 and 3 congruent. That's awesome, because what are the angles 1 and 3? Well, I know if these lines were parallel, 1 and 3 would be corresponding angles congruent. But I have 1 and 3 congruent, so therefore, lines must be parallel by the converse of the corresponding angles theorem. Now, converse of, notice up here, these were corresponding. So once I've proven in my steps that corresponding angles congruent, then I can use the converse to say lines parallel. And that's how you would walk through that proof, proving lines parallel. Now, what if you were given lines parallel? Pause this movie, try this on your own, and press play when you are finished. All right, given lines parallel. We've got A parallel to B given. 9 and 11 are supplementary, linear pair. You see 9 right here, 11 right here, and we've got A parallel to B. Now, 9 and 11, the measures are equal because the definition of supplementary. Now, what allows me to say measure of 11 must equal the measure of 14? By the alternate interior angles theorem. But why can you use alternate interior angles? Because A is parallel to B. And 11 and 14 are alternate interior angles. So that's perfectly fine to say. Then I've got 9 and 14 add up to 180 by substitution. So I took out 11, replaced it with 14. Substitution. Okay. We are going to work on this at another time. You may start your homework for this learning target. Thank you for watching the movie.